Okay, hello friends. I'm back with part 2 for application aware routing demo. What we are going to do is we are going to give you a live demo of how application aware routing works on our lab topology, what I'm going to explain you, and we will be focusing with the Cisco SD-WAN in Viptela's architecture. Okay, so without wasting time, let's go on live session. So the the overall video will go with the following agenda with topology explanation, and then we will directly jump onto our lab with explaining you the policy, what happens and why it happens, and then we are going to do an injecting a delay on the traffic between the two branches where the two hosts are getting communicated, and then we see the live magic. Okay, so let's kick off. So the live topology or the lab topology, what is going to have? We have two branches where we have host 10.3.0.10 in branch 1 and 10.4.0.10 in branch 2. So we have two service provider. One is MPLS and one is internet. We are just assuming we have two transport medium, and both the branches are connected with both the transport medium. Okay. And then the branch 2, which would be where we are going to inject the delay or the source of generating a traffic. It is having three interfaces: gigabit ethernet 0 by 0, which is the internet connected interface, and gigabit ethernet 0 by 1, which is our MPLS connected interface, and gigabit ethernet 0 by 2 is our LAN interface, which is running on VPN 10. Okay, and our WAN emulator is somewhere standing or connected with our gigabit ethernet 0 by 1 and 0 by 0 with a virtual instance of bridge 1, right, on which ethernet 2 is connected with our MPLS. Okay, so the policy what is been going to do or what is created is the MPLS link will always be preferred for all the traffic from branch 2 to branch 1, but there will be an metric binder on our policy, which is AAR, application aware routing policy, which is that you should have a delay of 50 milliseconds, latency of 2, and jitter 2, right? If any of this parameter gets defeated, then the traffic will automatically switch over to your internet without even your intervention. That is what we are going to see as a live demo. How things happens is, what I'm going to do is I'm going to inject a delay using a WAN emulator on the interface GE0/1, which is connected with our WAN emulator with a logical OVA interface, and you can see with the simulation on a GUI of Viptela we manage that before the policy or before the normal, before the delay introduced, the traffic was with MPLS. After the delay introduced, it went to your internet. And what happens is, if the WAN emulator or the delay was reduced again, then again the traffic switch over to your primary link without even intervention and without even a session break also. That is what we are going to see. Okay. So what happens is normally, so on normal scenario, I'm just going to repeat, the packet will flow via your MPLS, and in case of the latency or jitter or the SLA is getting breached, it will automatically flow over to the internet. Okay, so let's start and jump over to our lab. Let me just log in onto my lab. Okay, so my lab, you can see I have this is the dashboard. We manage dashboard where we have 7 VH routers and 2 V bombs, and yeah, the we manage what you are seeing as a dashboard, and 2 V smart controllers. So what we are going to say is, so I have 7. Let me just go to all the VH routers. So I'll be only playing in V branch 2 as per my diagram. Okay, so let me just jump on to branch 2, and let me just show you how the actual traffic flow is happening right now without even any policy. So let's go and see the simulation part, how the traffic happens. So when we go on to troubleshooting and simulate traffic flow, what we are saying is select the VPN 10, which is our data traffic for both the hosts running on VPN 10, and I'm just selecting the gigabyte Ethernet 0/2, what I've already shown as a source interface. So it automatically takes the source interface IP address. My host IP address was 10.3.10, which I've shown on that particular slide, and I'm just taking a protocol, which is one ICMP protocol. So I don't need to worry what particular port is actually, rest of the thing is automatically doing because it's a protocol. So let me just simulate the traffic, what happening is. So you can see right now there is no policies applied. So it is actually automatically going on both the transport lane. So you can see it's transport of MPLS on and off and transport of internet, right? So this is a normal scenario without even a policy applied. So it is automatically load balancing. I've not done any policy so far, just the basic branch connectivity. I mean, I've not shown that. That's just a part of simple template. So an IPsec tunnels are up, so it is automatically taking any of the traffic. So just to simulate that also, I'm just let me just do a ping from the branch 2. What I'm showing here is, you can see, so this is my branch 1 host. Source is the same thing, and VPN count VPN 10 and the count of 1000, and just started. So it will automatically, it will be just going continuously. So you can just think about that's a CLI based concept, and we are just simulating that stuff. So you can see the packet is actually moving, right? Just to see the traffic, how the things are getting load balanced. Let's see on the interface level as well. Just go to the network, RS2, interface. So let's see the real-time analysis. What is happening? You can see the interface G0Y0, 0Y1, and 2. So how the things happens. We need to be patient because it's an lab topology, so it will take some time to come up for the traffic to simulate. So you can just have a look. So you can see that the traffics are actually getting from your internet and as well as your MPLS load balance. Right? Can you able to see it? Yeah. So see, the yellow is the internet, and your green is your MPLS, and your somewhere dark green is the source. So you can see the traffic is actually getting out. Okay. So let's see now apply the policy. I've just created a policy here. So let me just explain you the policy. What is that policy means is actually. So before the policy, I would like to show you some custom list what has been created. So what I have done is I've just created certain SLA classes. For example, voice and video in SLA. This is the name of the SLA class, which says that you can bear up to loss of 1% with a latency of 15 millisecond and the jitter of 2 millisecond. Okay. This is what all the SLA class where you can define your own custom. So what I have created is from branch 2 to branch 1, you can bear a 2% loss with a latency of 50 millisecond and the jitter of 2, which is permissible for any traffic until the MPLS transport breaches these particular SLA parameters. Okay. So what we will do is I'll just show you the policy. So this is the policy or centralized policy which was created for application route, or you can say application aware routing policy. What it actually says is, you can say go on edit. So it is applicable to all the branches. I mean, because of the nature, because I want to apply the same thing on all branches on the corporate VPN, which is nothing but our VPN 10. It is a name given. So also added the DCs also because of VPN 10 is available on there. So what happens here is the traffic rule. You will see the traffic rule. So it says that I've created an application aware routing policy which is called as all traffic, and what it says is, you can just view on this one. So it says an app route policy what I've created. Anything with a data prefix on or data prefix for branch 1, it could be an destination IP protocol. From branch 2 to branch 1, it will always prefer MPLS. Okay, and you should log it, and in case the service class which was listed here SLA class, which I created as branch 2 to branch 1, where I said that 50 millisecond of delay is permissible with the 2% of jitter and some value of delay jitter and some class was there. So if that get breaches, you will automatically back up over to internet. Okay, so this is what the application aware policy, which has been created on this multi topology pulse, or maybe you can say that application aware routing policy, which actually speaks. And one point I just want to showcase you here also, that you can see the traffic rule. I'm just allowing all at the moment, so you don't need to worry for this. Traffic data is nothing but don't go with this one. It's just I just created actually. So you can think about the policy is ready. It's a simple application aware. What we are saying is, so what we are going to do is we're just going to activate this. So it will be automatically pushed to all my branches because I've already shared on the topology, right? So this is actually pushed from vManage to vSmart controller, and from vSmart the policy is actually pushed to all the DCs and branch wherever it is required, because we have selected on the VPN membership as all DCs and all branch, right? Okay, so let's wait till the policies get pushed onto our data center devices and as well as all the branches, which is as per our topologies branch 1 and branch 2. Super. So it has pushed without even any errors and stuff. So it is having a success result. So let me just see my policy. The traffic is still going. So let's again see the simulate the traffic. We go to network and branch 2 device. Go to troubleshooting. So let's simulate the flow now. So I'll select VP and 10. And let me select the source interface G/0 10.3.10. I'll select on a branch and protocol it with this. Voila. See, the policy what I was explaining is it will always prefer the MPLS traffic, irrespective of it. Earlier without policy it was automatically load balancing. See the power of the policy also. So we have just lively demonstrated that without any policy it was actually taking both the IPsec or both the transport medium. Now the policy what I have explained, that has been applied and it has automatically taken only the MPLS interface, right? So where we can say that our policy is working fine. So let's go and see the interface stats also before we apply a delay on that. So let's see the stats. So you need to be aware with us because of the lab topology. The simulation can be upside down. So let's be for some time. 1, 2. So it's came up. So you can see that G1 is more and internet has come down. So the traffic is actually going via MPLS at the moment. Okay, see, you can see that. Yeah. So now the actual application aware routing power is going to come. So we have a WAN emulator. You can see here. What I have selected is BR1. So BR1 is a bridge which is actually connected with my branch router 2 with Ethernet 2 on MPLS interface and Ethernet 3 on internet interface. What I'm going to inject is, I'm just going to inject a load of 45 milliseconds. What I'm saying, just give me a sec, it should be, set the setting, let me just select the bridge BR1, select bridge here. So what I'm saying is the delay what my policy was, sure, let me just rerun the policy for you guys so that you guys know what was the policy was actually. The policy was, what we are saying was that was the SLA class. Let me show you the SLA class. SLA class was BR2 to BR1, which says that the latency or the delay, which is actually 50 millisecond, is the bearable. Okay, so what I'm going to do is, let me just pump it out with 100 milliseconds, or you can say 55 milliseconds. Let me just do that, just 5 milliseconds, and see what the things happens. So So now say the WAN emulator command successfully created. Now it is actually pumping a delay of 57. Let's see the current stats. So you can see on the Ethernet the delay is 55 milliseconds. The packets of 1000 is being limited. Let's do this and the packets are going. Now let's see what happens to our application aware routing policy for the branch 2 devices. So as per the policy, because the delay is exceeded the 50 millisecond, now it should automatically will switch over to our internet link without even my intervention. So let's see it 10.3.10 and you have let's see, voila, see the magic. See the magic. Nothing has been done from my side, so now that's been showing us internet connection. And you see the ping, there is no breakage. No breakage, no breakage. So session is seamless failover without even an intervention. Seamless. It's seamless. See, this is where we say that the service availability or the user performance, or the, even you can say that user was not aware. Nobody knows when that nothing's actually gone to your internet. See the power. This is what called application aware routing, which is giving high performance of benefit with the help of SD-WAN technology, right? Let's reduce, now let's play with this delay. What happens if I just reduce to 45 milliseconds by setting? Okay, so let me just see the current status. So it says that the delay is reduced to 45 milliseconds. Let's refresh it. So again, you can see that live scenario, right? When MPLS link got reduced, what happens then? So let's see. So shall we simulate again? What happens now? Super. See the power of policy, the power of BFD, the power of application aware routing, which the BFD was polling every second. I said in my previous video, right? And the BFD actually has tracked the delay, and application aware routing has leveraged BFD and it has turned back the traffic because the SLAs were getting met as per our policy. Marvelous. That is where the power of application aware routing comes, what we are seeing as a live demo right now, guys. I'm not manipulating anything, it's a live demo. So you can see. So another test we'll see with 50 millisecond, which is actually our SLA metric. Will that give any difference? Let's see that as a final cut. So we are seeing that, yeah. So let's see how things happens. Let's wait. See, it's not yet breached. That is what the policy says. Policy says till 50 milliseconds I'm okay. If you go 51, let's see. Let's check the status. So it says 51. So as per my policy, it should have flipped over to internet without even my intervention. Okay, let's see the magic. Awesome. See, that's the beauty of application aware routing. Nobody knows what is happening in the user traffic. I'm not seeing any dip, no session break between the link whenever we have done the policy changes or introduced delay, and we have seen the live demo now. So that is what I'm saying, the power of application aware routing, which actually makes sense in our enterprise world. What happens is, so what happens if there is a brownout issue? The user performance get degraded, but we never ever come to know the reason or the transport link, what transport link I need to choose, because we always think from the availability point of view. Application aware routing has actually come up or overcome those issues, and it actually gives you enhanced user application performance because it is actually checking the status or the health of your transport. and based on that it's intelligently deciding what transport is best suited for the application so that user is always happy, right? So you can leverage application aware routing even on a worst link because the health of the transport is getting checked every second, and with an intelligent algorithm the application traffic is sent on all the best suitable link. Okay, so with this I would just like to say thank you for seeing this live demo on application aware routing, and I would like to thanks for people to watching this video, and please come up with your feedbacks and do let me know for future topics where we can spend some quality time and discussion, and please subscribe this video for more talk. Thank you very much.